Today we are going to solve exercise 2.3. But before solving that exercise, we need to understand what is remainder theorem, as the complete exercise is based on this remainder theorem only. So remainder theorem says that let px be a polynomial of degree greater than or equal to 1 and let a be any real number. If px is divided by linear polynomial x minus a, the remainder is pa. Okay, I'll just explain you what this means and then we will apply this in this question. Okay, it is saying if px is a polynomial, okay, whose degree should be greater than or equal to 1. It should not be a constant polynomial. Okay, degree should be greater than or equal to 1. And if you are dividing this polynomial by a linear polynomial x minus a, this polynomial should be linear, that is x minus a. Then the remainder what you will get, that will be equal to pa. Okay, this will be the remainder pa. Means in place of this x you need to place this a, that will be the remainder. Now let's apply this theorem in this question. This question says you need to divide this polynomial by this 5 parts and you need to get the remainder using remainder theorem. Okay, so what we have said, there should be a polynomial px whose degree is greater than or equal to 0. So here we have a polynomial, this is px, whose degree is 3 here because variable is having highest power of 3. So we have the degree which is greater than 1. And when this is divided by a linear polynomial, all the polynomials given here are linear. Suppose when we are dividing this polynomial by this linear polynomial, that is x plus a, then we need to find the remainder. Now in place of this x minus a, we have this x plus 1. Okay, now we'll compare this x plus 1 is equal to 0, because from where we got this a, when we compared this x minus a is equal to 0, so we got x as a. So we are putting the value of x as a in this polynomial to get this remainder. Okay, so we will compare this x plus 1 is equal to 0, so that we will get the value of x as minus 1. Now we will put, I am solving this first part. Okay, now we'll put x is equal to minus 1 in this polynomial. So p of minus 1, that will be equal to minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. Okay, let us solve this. Minus 1 cube is minus 1, minus 1 square will be 1 and it is plus 3. This will be minus 3 and this will be plus 1. Okay, so plus 3 minus 3 cancels, minus 1 plus 1 cancels. So we'll get p of minus 1 is equal to 0. And this 0 will be the remainder of this polynomial when you divide this by x plus 1. Okay, I hope you understood what is remainder theorem and how we will use this. Let us take the second part. That is, second part is x minus 1 by 2. Okay, when you divide this polynomial by x minus 1 by 2. Again we will compare this x minus 1 by 2 by 0, so that we will get the value of x as 1 by 2. Now we will get the value of p of 1 by 2. Okay, just replace the value of x by 1 by 2. That will be 1 by 2 whole cube plus 3 into 1 by 2 square plus 3 into 1 by 2 and plus 1. We'll just get the value of this to get the remainder. Okay, now when you further solve this, it will be p 1 by 2 is equal to 1 by 2 cube is 1 by 8 plus 3 into 1 by 2 is 1 by 4 plus 3 by 2 and plus 1. Okay, now 1 by 8 plus 3 by 4 plus 3 by 2 plus 1. Let's get the LCM. LCM will be 8, 1 plus 6 plus 12 plus again 8 here. Okay, that will be 7, 7 plus 12, 19, 19, that is 27 by 8. This will be the remainder. Okay, I hope you understood the concept here. Let us see the third part. Third part is what? X is equal to 0 if you compare. So we got x as 0 only because no constant is there. So value of a, if you compare this to x minus a, then value of a is what? 0 only. Okay, put the value of x as 0 here. So that will be p of 0 is equal to 0 cube plus 3 into 0 square plus 3 into 0 plus 1. Okay, so each term will become 0. This last one will remain. So p of 0 we got as 1. So the remainder of this polynomial, if you divide this by x, we'll get as 1. Okay, let us see the fourth and fifth part also. Fourth part is x plus pi. Okay, so if you take x plus pi is equal to 0, so x will be equal to minus pi. So we will replace the value of x by minus pi. So p of minus pi will be minus pi whole cube plus 3 into minus pi square plus 3 into minus pi plus 1. Okay. Now minus pi cube is what? Minus pi cube only. Minus pi square is pi square. So that will be 3 pi square. This will be minus 3 pi plus 1. And this is only the remainder. We cannot further solve this. So this will be the remainder. Moving to the last part, that is fifth one. So we'll assume 5 plus 2x is equal to 0. So from here we will get 2x is equal to minus 5 and x will be minus 5 by 2. Okay. Now we will get the value of this polynomial at x is equal to minus 5 by 2. So p of minus 5 by 2, that will be equal to minus 5 by 2 whole cube plus 3 into minus 5 by 2 square plus 3 into minus 5 by 2 plus 1. When we solve this, we get this minus 5. So minus will be minus only, minus cube is minus. 5 cube will be 125 and 2 cube will be 8. Plus this minus square will be plus, and this 3 into 5 square is 25 upon 2 square is 4. This will be minus, minus plus, that will be minus, 3 into 5, that will be 15 by 2 plus 1. Okay. Now it is 125 by 8 plus 3 into 25, that will be 75 by 4 minus 15 by 2 plus 1. Take the LCM. LCM will be 8 here, that will be minus 125 plus that will be 150 minus that will be 60 plus 8. Now add the above portion, that will be minus 125 plus 60, that is 185 plus 150 plus 8, that will be 158 divided by 8. Now we need to subtract this 185 minus 158. That will be 27, and as negative is with greater number, so that will be minus 27 by 8. So this will be the remainder, that is p of minus 5 by 2. Okay, so I hope you understood what is remainder theorem and how we apply this in the question. Let us move to the second question. So question number 2 is, you need to find the remainder when this polynomial is divided by x minus a. Again, here we have a polynomial whose degree is greater than or equal to 1. We know the degree is 3 here, so it is greater than or equal to 1, and it is divided by a linear polynomial x minus a. So the remainder is what? PA. Okay, we will compare this linear polynomial, this will be the solution, x minus a to 0. So we will get here x is equal to a. Now we will put this value of x as a in this polynomial. Okay, so that will be p of a, that will be equal to a cube minus a into a square plus 6 into a minus a. We just replace the value of x from here, x is equal to a to here. Okay, so when you solve this, it will be a cube minus a into a square, that will be again a cube plus 6a minus a. So this will get cancelled. 6a minus a, that will give you 5a. Okay, so this will be the remainder when this polynomial is divided by x minus a. Okay, the concept is very easy, and this question number 2 and 3 are the application of that remainder theorem. Okay, so this becomes very important. Now this PA, the remainder here is what? 5a. Moving to third question, we need to check 7 plus 3x is a factor of 3x cube plus 7x. We need to check this. Okay, so what we'll do, we'll again find the remainder only. If we will get the remainder as 0, then we can say that this 7 plus 3x is a factor of this. So we will take a linear polynomial, that is 7 plus 3x, this will be the solution, is equal to 0. So from here we will get 3x is equal to minus 7 and x will be equal to minus 7 by 3. We will just replace the value of x as minus 7 by 3 in this polynomial where degree is greater than or equal to 0. So we'll get p of minus 7 by 3 is equal to, that is 3 minus 7 by 3 whole cube and plus 7 into minus 7 by 3. Okay, when you solve this, you will get this minus will come out and this 3 multiply this minus 7. Okay, so minus we have already taken. 7 cube is what? 343 divided by this will be 3 cube will be 27. This plus minus will become minus and this will be 49 by 3. This 3 will cancel this 27 by 9. Okay, so if you take the LCM, it will be 9, and here it will be minus 343 minus, we need to multiply this 49 by 3, that will be 147. Okay, now when you solve this, you will get minus, that will be 490 divided by 9. Okay, this will be the remainder. So since we are not getting the remainder as 0, since you can write, since p of minus 7 by 3 is not equal to 0, so we can say that the 7 plus 3x is not a factor of 3x cube plus 7x. Okay, these two are the applications of remainder theorem. I hope you understood the concept of remainder theorem and the questions related to it. Thank you.